In this video, we're going to talk about independence in the multiplication rule. So previously, we talked about probabilities with or not. In this video, we will talk about probability problems with the word and. But first, let's discuss independent and dependent. So two events are independent if the occurrence of one event doesn't affect the probability of another event. Two events are dependent if the occurrence of one event does affect the probability of another event. All right, let's take a look at some examples. So tossing a coin, then drawing a card from a standard deck. Yeah, those two events do not affect each other at all, so this is an example of being independent. Drawing a marble from an urn, not replacing it, then drawing a second marble. Well, yes, that does affect the second marble because you're not putting the marble back in. That's what is called without replacement, so these events are dependent. And then driving on ice and having an accident, clearly the ice will have some effect on your driving, so that is dependent. So, disjoint events versus independent events. It is important to know that disjoint events and independent events are different concepts. Recall that two events are disjointed if they have no outcomes in common. That is, if knowing that one of the events occurs, we know the other event did not occur. Independence means that one event occurring does not affect the probability of the other event occurring. Therefore, knowing two events are disjoint means that the events are not independent. Okay, let's go to an example then. So suppose you toss a coin, then roll a four-sided die. What is the probability you will get a tail and then roll a 4? So I'm going to draw what's called a tree diagram for this problem. This is a picture that shows all possible outcomes. Well, let's start with a coin. It's either going to land heads or tails. So I can draw the tree part with a four-sided die. It's going to be 1, 2, 3, or 4. I can draw the branches for the tails also. Okay. Now, the sample space I'll write out here. So heads and 1, that's one possible. Heads 2, heads 3, heads 4. And then I can do the exact same thing for the tails. Tails 1, tails 2, tails 3, and tails 4. So it looks like there's 8 possible outcomes that can occur for this. So again, the probability is asking of getting a tail and then a 4. Well, that's going to be 1/8. Okay? One possibility, tails and 4 out of 8 total. Now, is there another way that I can look at this? Well, the probability of getting a tails is 1/2. The probability of rolling a 4 on a four-sided die is 1/4. Well, what basic operation can I put in between these numbers that would get me to 1/8? Well, clearly that's going to be multiplication. 1/2 times 1/4 is 1/8. All right, the multiplication rule for independent events. If the following events are independent, then it would be what? E1 times E2 times E3 ... times e to the n. All right, so let's take a look at some examples. Suppose there are 3 people in a room and you ask each person when their birthday is. Assume it's a non-leap year, meaning what? There's 365 days in a year. What is the probability that one person's birthday is September 23rd? Okay, so the probability birthday September 23rd. One date, that's September 23rd, out of 365. Now, what is the probability that the first person's birthday is September 23rd and the next 2 people don't have a birthday on September 23rd? Well, let's start with the first person. The probability of the first person having a birthday on September 23rd is 1 out of 365. Now, the next 2 do not have a birthday on September 23rd. Well, how many days? That would be 365 minus 1. There are 364 other days of the year that are not September 23rd. So times 364 out of 365. The third person's birthday has nothing to do with the second, just like the second person's birthday has nothing to do with the first person's birthday. So this is also 364 out of 365. Multiply, I get this. Again, I'm not interested in reducing the fractions in the lowest terms. Okay, part C. What is a probability that all three people have his or her birthday on September 23rd? Well, probability of the first, 1 out of 365. Again, the second person's birthday has no effect on the first. So 1 over 365 times 1 over 365. But notice, I don't have to write the word "and" for this problem. It's the probability the first person has a birthday on September 23rd, and the second person has a birthday on September 23rd, and the third person has a birthday on September 23rd. So the word "and" is not there, but it is assumed. Okay? This is the same thing as 1 over 365 cubed. Multiplying that out, that's this. Okay, part D. What's the probability that at least one person has a birthday on September 23rd? Again, remember, we're still talking about three people in the room. All right, so the probability of at least one birthday, September 23rd, is 1 minus the probability of 0 people have a birthday on September 23rd. So again, 3 people. So the probability of not having a birthday on September 23rd, 364 out of 365. Second person not having a birthday on September 23rd, same. Third person, exactly the same. This is the same thing as this. Okay, let's take a look at the next example then. So suppose you have a 4-question quiz in which each question has 3 choices, A, B, or C, and only one answer is correct. You haven't studied, so you randomly select an answer to each question. What's the probability that you will only answer question 1 and 3 correct? So you know you're getting 1 and 3 correct. What is that telling you about questions 2 and 4? You miss them, right? I'm going to write 2 and 4 are incorrect. Okay. 4 spots because it's a 4-question quiz, and I'll write A, B, C, to remind ourselves that each question is A, B, or C. So the first question is correct. What's the probability you're going to get it correct? There's 1 correct answer out of 3 choices. And the probability of getting the second one wrong, 2 incorrect out of 3. And getting the third correct, 1 correct answer out of 3. And getting question 4 incorrect, 2 incorrect out of 3. That gives me 4 out of 81. Which is approximately this. Not very likely. Again, make sure you leave your answer as a fraction. All right, part B. What is the probability that you will answer all questions correctly? Okay, so again, I'll write ABC. What's the probability you're going to get the first question correct? 1 correct answer out of 3. And getting the second, 1/3. And the third, 1/3, and the fourth, 1/3. Multiply, that's 1 out of 81, which is this approximately. Again, I want the fraction. Okay, part C, what is the probability that you will get at least 1 question correct? So again, probability of at least 1 correct is the same thing as 1 minus the probability of getting 0 correct. Now remember what that means then. All 4 answers are incorrect. That's what that means. So it's 1 minus parentheses. Probability of getting the first one wrong, 2/3. And the second one wrong, 2/3. And the third, and the fourth. That's 16/81. That's the same thing as this, which is 65/81, which is approximately this. I guess the moral of the story is you probably should study, because it looks like the chance of getting at least one correct is a little bit more than 80%.